I'm gonna be talking about limit today. If you know what the word approaches means, then do you know what the word limit means? When you're given a limit to evaluate, like let's say a limit that looks like this, as x approaches c of f at x, you're basically being asked what happens to my function f at x when x approaches c. I'll give you a better example to kind of demonstrate it clearly. Like let's say I'm giving this function f at x, and let's say at this point it was equal to c. If I was to evaluate the limit as x approaches c of f at x, then I would just state this point here, right? For example, let's say I had the function 3x plus 5, and then limit as x approaches 3. Now this graph will look a little something like this, and when x is equal to 3, y would equal to 14, right? So when I evaluate this limit, it would equal to 14. Now you might be asking yourself, what is the point of this? Why don't I just give f at 3? Why is there some limit here, right? Well, this limit is needed when my function becomes undefined at a certain point. For example, at a function like this, let's say, and then this point right here was c, comma, f at c. I can't just give f at c, right? Because it's actually undefined. Sorry. Just state that more clearly. This is undefined, right? I can't give you the value that f at c holds because it doesn't exist, right? But I can tell you very closely which number this approaches, right? So let's say this number was equal to 4, right? Like in the coordinate grid, it will be c comma 4. I would say that limit as x approaches c would equal of f at x would equal to 4, right? And there's something else. If I had a function like this, we'd call it jump discontinuity. And the thing about limits is that when you approach it from both sides, you could think of it as like I'm squeezing a certain point. It has to equal the same number, right? So let's say this point was like c comma 3, and this point right here was c comma 5. Then the limit as x approaches c from the negative side would equal to 3, but the limit as x approaches c from the positive side would equal to 5, right? And if we have a situation like this, we say that the limit as x approaches c of f at x does not exist, right? So every time we're given a limit to evaluate, you have to make sure that the limit from both sides is equal, right? So let's write that down more algebraically. For limit as x, sorry, um, if limit as x approaches c of f at x exists, then limit as x approaches c from the negative side would equal to the limit as x approaches c from the positive side, right? So whenever I'm given a graph, and let's say there's a discontinuity here, I have to make sure that my left hand and right side both approach the same number. Let's just